especially with solidity. And it kind of makes it easier to maintain these functions when the arguments start getting long and you're using get and things like that. Sometimes I will just break these up like this. All right, and then I'll actually put the modifiers. If you have a bunch of modifiers, sometimes this makes it easier to read. And also when I'm writing my own Solidity source code, I only use 2 spaces. I don't use 4. But yeah, that's sometimes how I break these functions up. So I can see the function name and then the arguments. Then I can see the modifiers, and then I can actually see the code that gets executed inside here. And it can make your smart contract kind of long, but it can be... Sometimes this will catch you if you have too many, if you have 3 visibility and modifiers on here, sometimes it can be kind of tricky. So I like doing this. All right. So next, I'm going to show you how to work with time in Solidity. Okay. So what we can do is basically compare time in Solidity. And instead of this saying only owner can do this, let's say that you can only call this function if a certain time has passed. So let's pretend like, this is a contract that is only open at a certain time. So we'll say instead of only owner, we'll say only while open. Only while open. All right. And this opening state is going to be determined by a time. So once we've passed a certain time in history in the future, then we'll let you call this function. If it's before that, we won't do it. So that's really useful if you're building a crowd sale or something like that has an opening time, like an ICO smart contract, and you say, hey, we can only let you contribute Ether after the first of the month. Well, you just figure out what time that is and say, hey, if you make a contribution before then, we'll throw an error. So I'll say only while open. All right. And instead of requiring that MSG, that sender is the owner, right? We're actually going to just take this out. We're going to say, we're going to make sure that the current time is in the future, beyond a certain opening time. So let's do uint 256 opening time. All right. So how do we do this? Well, we need to set this opening time somehow. All right. So the opening time is actually expressed in seconds, inside Solidity, or these timestamps are expressed in seconds inside Solidity. And seconds of what? Well, it's epoch time, which if you're not familiar with that, it's a concept in computer science that's the epoch is a specific time. I can't remember the actual date. It's a date in the 60s or 70s or something like that. And basically, we just add seconds since that point in time in history. So this is the current epoch timestamp is this many seconds since the epoch time. And I guess there's probably a link here where you can read more about that. Yeah, the Unix epoch clock. Yeah, I'm sure you can get on Wikipedia and figure all that out. But basically, this is the current epoch time and it's changing. So we use these seconds values. So this is the current, epoch timestamp. We'll say this. All right. So this is how we could set this. And it's, uint 256 is going to store this big number of seconds since that timestamp. And that's going to be our opening time. And so how do we compare that to now? So how do you get now in Solidity? Well, there's no perfect way to do it, but the best way is to get the current block's timestamp. All right. So how do we do that? Well, just like MSG, there's a global variable in Solidity called block. And we can say block.timestamp. All right. And we can say, is the block.timestamp, is it greater than or equal to the opening time? All right. So basically, if it's after the opening time, we're going to let you call this function. And if it's not, then we won't. All right. So let's give this a try. I'm going to update this timestamp. Let's refresh it. Let's see. This is the current one. I'll paste this in here. So 15. I'm going to add 60 seconds, so a minute. So I'm going to deploy this, and it will be... it shouldn't work right now, so we can try to call add person. We'll try to add DAP University. Okay, we'll add person, and we'll see that it reverted. Okay. And now we can check the timestamp. We're not there yet, so I'll just pause the video and wait for this to pass 75. I think that's the actual time. Yeah, 75. All right. I'll pause the video. Pause the video, giving us plenty of time. We're past the timestamp. You can see it's 793 and we're at 775. So let's deploy it again. Well, actually, let's not deploy it again. Let's just do Joe Blow, add person, and it worked. So that's how you can use time and Solidity. You can get the current time and set a time value with seconds. And so that's what I'm going to call today, guys. I hope you all like this video. Let me know how you're enjoying these Solidity videos. Let me know if I've missed anything or if there's something you want to learn, or if you're just not liking them, that's okay too. Just let me know down in the comment section below. Let's use the same My Contract example that we've been using throughout this tutorial series. And you don't necessarily have to have been following along with every video in this series. You can kind of just pick back up with this one probably. So yeah, let's go ahead and jump in and start programming. What I'm going to show you first is how to write a function that accepts Ether. So basically, like, how can we send Ether in when we call a function and do stuff with it? So I'll show you how to do that. First, we'll create a function called buy token. Say buy token. And this function is going to kind of emulate what happens in an ICO, like a crowd sale or a pre-sale or something like that on Ethereum, where you're buying ERC20 tokens. I'm not going to like code out an entire ERC20 token smart contract right here, or code out a crowd sale smart contract. I've got several other tutorials that show you how to code your own cryptocurrency on Ethereum with build an ERC20 token step by step and a real world crowd sale, things like that. So you can check out those other videos if you're interested. But what we're going to do is basically create this function called buy token that's going to simulate what happens. It's not going to do everything, but it'll at least give you an idea of how that works. So we'll call this buy token. And inside here, what we basically want to do is buy a token. And we also want to send Ether to the wallet. So what's going to happen is someone's going to call this function, and they're going to send Ether when they call this function. And when they do, we're going to issue them a token. And then the wallet is actually going to receive the Ether that they sent in when they call this function. So I'll show you how to do that. First, I'm going to create a way to track the tokens. And basically all this is going to do is track this person's balance. So we'll use a mapping for that. We'll say mapping. And again, if you didn't check out the other videos, the mapping is like an associative array where we have key value pairs. So we'll say address will be the key and the value will be an unsigned integer. All right, and this will be public. All right, this will give us a function for free that will allow us to read this value. And we'll just call this balances. So what we'll do, and when we buy a token, we'll basically just say balances of whoever called this function. So if you'll remember from the last videos in this series, we get that value with msg.sender. This is the account that's calling this function. And we will just increment this count by 1. Now, this is not really fancy. We're basically just saying whenever you call this function, you're going to buy 1 token. We're not using a rate of redemption or anything like that. This is just to kind of show you how this works. This is not very sophisticated. But basically, that'll just increment your balance, inside this token contract by 1. Whenever we do that, we want to transfer funds that are sent in with this smart contract to a wallet. All right. So how do we do that? Well, first we keep track of a wallet. We'll just declare a state variable here. We'll say address wallet. And we want to send funds to this wallet. Okay. And we do that like this. And I'm actually going to show you something in a minute that's going to be a Solidity 0.5 update. So if you've been using previous versions of Solidity, we have to make a change here. I'll go back to that in a minute. But anyways, let's transfer funds to this wallet. We'll do that like this. So we'll say wallet transfer. And we want to transfer in the funds that are sent by this function. Transfer the funds that are sent in by this function to this wallet. So how do we do that? Well, how do we actually know what the value is that's getting sent in? Well, just like msg.sender, MSG has another property called value. So we can say msg.value. All right. And that's going to tell us exactly how much Ether or Whey is sent in by the person who's sending this function. So I'll show you how that works. So what that's going to do is take the ether that's sent in with this, function call and transfer it to this wallet right here. Now this is not complete. There's a lot of things that actually need to change in order for this to work properly. You can see these X's over here, these, compiler errors. So the first thing we need to do is set a wallet. Let's do that inside a constructor. We'll do that whenever we deploy the smart contract. So we'll say constructor. We'll say address, wallet. We'll say public. And we'll say wallet is just equal to the wallet we pass in. All right, so we're still getting errors. Now let's see what they are. The first thing we need to do in order to make this function accept ether, well, actually, first we need to make it public so that people can call it. We say public. All right. So now people will actually be able to call this function and send ether in and stuff like that. And in order for this to accept ether, we have to add another modifier here, which is payable. All right. And if we don't do that, this won't allow us to send ether in with the transaction. So this is how we declare that this function will accept ether, okay? Now here's a new Solidity update. It requires explicitness whenever you're declaring an address that can accept ether inside of a smart contract. And we do that like this. We say address payable wallet, all right? And then likewise, we say address payable wallet whenever we pass this function into the constructor. All right, so that should be a working implementation of what we want to see. So let's deploy the smart contract and try it out. I will take one of these addresses, and we'll take the second address here in the list, and we'll use that as the wallet. We'll actually check its balance here in a second. So we'll deploy the smart contract. We need to pass in a wallet whenever we deploy. Just paste this in, click deploy. All right, looks like it was successful. Let's try to do the buy token function, okay? It's just going to buy one token for us. So we'll make sure we've got the first account in the list selected. We'll buy token. All right, looks like it was successful. Let's check the balance of this. Oops, I actually pasted in the wrong address. Pasted in the second address. So let's try the balance again. All right, it's 1. All right, now all that did was actually transfer, all that did was buy a token. It didn't actually transfer ether to the wallet, and that's what we want to show. So in order to send ether in and actually transfer funds to the wallet, we would do that like this. We'd change this to ether. I'm going to send 1 ether in with this transaction whenever we call the buy tokens function. We'll do that from this account, and we'll click buy token. All right, boom. So let's check the balance again. All right, the balance is 2. Now, let's see what happened. We can see that the ether value decreased here from 99.9 to 98.9. It actually took ether out of our wallet because we sent it in with the transaction. And we can see that the second account on the list, which I used as the wallet whenever we deployed, has been credited with that ether. So our smart contract worked. It actually sent, the value that we sent in with this to that account. All right, so the next thing I want to show you is how you can create basically a fallback function in Solidity. I guess is what it's called. At least that's what I've seen it called. I'm not sure what the official name is. But basically, it's going to be like a default function that you can wrap this in so that whenever you just send ether to the smart contract, it executes a function. And you'll see that a lot in ICOs where they have an address posted and they say, hey, send ether to that smart contract, and it'll actually buy the tokens for you. Now, this is just a kind of pseudocode implementation, again, of a purchase function. A real ICO functionality would be much more complex than this, but you get the idea. So to do this fallback function, we'll do like this. We'll just say function, all right, and we'll say external payable, and we'll just wrap this with the buy token function. All right. So here's a new modifier I don't think we've used yet, which is external. So that's different from public, because public can be called, inside of our smart contract as well as outside, but external can only be called outside. So we don't want to call this, inside the smart contract somehow. So now if we just compile this again and deploy, I'm going to paste the wallet in here, deploy. We'll see you have a new function just called fallback. And we can basically just do that like this. So we'll just send one Ether from account number 1, call the fallback, and it worked. We can see our account balance went down, this went up, and the balance of the first account should be 1. Yep, it's 1. So now I want to show you events inside of Solidity. So what do we use events for? So events are a way for external consumers to kind of listen for things that happen on a smart contract. So basically, external consumers can subscribe to events on a smart contract and wait for something to happen. So what we'll do inside of this buy token function, we'll actually trigger an event that lets anyone connected to the blockchain really to know that a token has been purchased from the smart contract if they were to listen for it. So I'll create an event like this. Do it up here. We'll say event purchase. And I'll just say, I'll break this line right here. Oops. I'll say address. Buyer. I'll say UINT 256 amount. Okay. So that's how we declare an event, just like that. And inside of this function, whenever the token is purchased, we'll trigger it. And we trigger the event like this. We say emit purchase.